All right, so we're going to continue on with what we started yesterday, finding the zeros of polynomials. So if the leading coefficient isn't 1, the possible zeros can end up being a long list, and we saw that last night on our homework, right? One of them had a list of, well, it was 16, but they were all plus or minus, so 32 possible roots for one of the problems we did last night, right? So do you want to test 32 possible roots? That would kind of be a lot of synthetic division. I know if you like synthetic division, maybe you'd be into it, but yeah. So that's a lot of synthetic division. So one way that you can limit your search or narrow the list is to use a graph. And so a few of the problems that you have tonight, they actually give you a graph. So you can use a graph to narrow the list down. So if we look at this first one, I'm going to find all the real zeros of 4x cubed minus 7x plus 3. And the graph I did from Desmos online graphing calculator. But like I said, the ones in the book tonight, they'll have them for you. There weren't a lot of examples for me to pull from for this, so I had to create it myself. All right, so if I look at my possible zeros for this one, the list actually isn't horrendous on this one. My factors of 3 are just 1 and 3, right? And my factors of 4 are 1, 2, and 4. So 1 over 1, 3 over 1, 1 over 2, 3 over 2, etc. If I look at the graph, though, I can see that it looks like 1 is probably a 0. So right off the bat, I know I should try 1, because from the graph I can see that it's a 0. So if I try 1 with synthetic division, my coefficients are 4, negative 7, and 3, but am I missing something? Which term is missing? The x squared. So I'm going to have a 0 after the 4, and then negative 7 and 3. So doing the synthetic division then, I bring down the 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is still 4. And then negative 7 and 4, I get negative 3. 1 times negative 3 is negative 3. And then I have 0. So sure enough, 1 is a 0 for that polynomial. So now I'm left with 4x squared plus 4x minus 3. So at this point, I could factor it, or I could decide to do synthetic division again, since I've got the graph right there, and it looks like 1/2 will probably work. I don't feel like factoring today, so I'm going to try 1/2 and see what happens. All right, so I bring down my 4. What's half of 4? 2. 4 and 2 are 6. What's half of 6? 3. And then that adds up to 0. So now I'm left with just 4x plus 6. And I can just set that equal to 0. And so 4x is equal to negative 6 divided by the 4. And I get x equals negative 3/2, which looks reasonable from my graph also, doesn't it? So now I have all my zeros. Negative 3/2, positive 1/2, and positive 1. Now, with this graph, it was pretty easy to tell what the zeros were. The ones on your homework, it's not quite as obvious, but there will definitely be at least one root that's obvious for you to try. So from there, then you're just either factoring, or you can continue one more step of its synthetic if you want to. So any questions on what I did there? You guys need a sec to write it down? Okay. All right, so here's one more example. With this one, you can see that we would end up with a pretty long list of potential zeros, because 48 has a lot of factors. It's 1 times 48, it's 2 times 24, it's 3 times 16, it's 4 times 12, it's also 6 times 8. So we've got a lot of potential factors on this one. 40 potential factors. Do we want to try 40 different ones, especially when most of them are fractions? No, we don't. That would just not be fun. But if I look at my graph here, it looks like this is probably positive 1/2. Notice that the scale on the graph for this one is by halves. So 1 and -1 aren't going to work if I try them. But 1/2 should work as near as I can tell from the graph. But of course, I can't be positive until I try it. So I'm going to try 1/2 and see what happens. So we've got 48, 4, -20, and 3. I bring down the 48, and half of 48 is 24. Add those together and I get 28. Half of 28 is 14. Add those together I get -6, and half of -6 is -3, and sure enough it works. So now I have 48x squared plus 28x minus 6. So at this point I could factor it, or I could decide to do synthetic division one more time. And I feel like doing synthetic division one more time. Because I look here, and that sure looks like what? What do you think that is? Could it be -3/4? And is that something that we could have based on our list? It is. So let's see what happens if I do -3/4. All right, so I bring down my 48. So if you want to do something like -3/4, you can do that in your head. Just what's 1/4 of 48? 12, right? And then I just do 12 times -3, and I get -36. If I add those together, I get -8. So what's 1/4 of 8? 2, and then it's negative. So, but a negative times a negative, 2 times 3 is 6, and then I get a 0. So that one also worked as a 0, and then I'm just left with 48x minus 8 is equal to 0. And so 48x equals 8. We divide by 48. What's that going to reduce to? 1/6. So now I've got my zeros. And does 1/6 seem like a reasonable estimate for that last point? Yeah. But is that one that you would have necessarily guessed? It could have been 1/6. It could have been 1/8. So now we know for sure. So my zeros for this one then are -3/4, 1/6, and 1/2. Okay. Any questions on that one? No? All right. That's all we have for today. I just wanted to do those 2 examples for you so you guys have the rest of the time you can work on your homework. All right? Okay. Thank you.